Hello everyone, welcome back to our channel. In today's video, we are going to solve trapping rainwater. Which is very important and frequently asked question in TCS NQT. If you are preparing for TCS NQT, Infosys, Wipro or any other service-based company, this problem is must know. Question like this test your logic, array understanding and problem solving skills also. Watch this video till the end. Let me first give you a quick overview of the problem. You are given an array where each element represents the height of a building. After raining, how much water can be trapped between the buildings? Now our task is to calculate the total amount of trapped rainwater. There is a condition. Water can be trapped only if there are taller buildings on the both sides. If the building is shorter, can we trap the water in between the buildings? No, right? If the building is height, if it's have a height on both sides, at least one side is minimum and other side is maximum, we can store the water up to minimum, right? If it's higher, we can store the water there. Before we start, make sure to subscribe to this channel and I regularly upload important TCS level coding questions with clear explanation. Let's take this example, which is commonly used in TCS level questions and in Infosys, Wipro, and so many companies also. So here is a diagram, and this is a array value. So in this value, the black bars which represent the height of the building and blue bars which represent the trapped water between the buildings. Width of each building is 1 unit, right? At first, in a first element, the value is 0. There is no building. After that, we have 1. The height of the building is unit 1. And after that, 0. There is no building. After that, we have a 2. So, the height of the building is 2. According to the value, the height will be differ. And the blue represents the water, which is trapped between the buildings. Here the height. If it is height, if it is have a height, we can store the water can be trapped. We cannot trap the water here because before we don't have any building. This is our starting building. We cannot trap any water here. So here we have here we don't have any building, and after to this we have a 2 unit building, right? Its height is 2 unit. Here we have a 1 unit and here we have a 2 unit. We can store up to 1 unit. If we have here 2 unit, we can store the water up to 2 unit, but we have here only 1 unit and here also we have 2 unit. Here we have a 1 unit compulsory. We can store the trapped water up to here 1 unit. And comparatively, this is what our maximum height of the building. Here we have a 3 unit, and in this building we have 2. If we have here 3 and here we have 2, we can store the water unit up to 2, right? Our task is to find how many units we can trap between the buildings. Here 1 and 2, here 1 unit 3, and here 4, 5, and 6. Totally we can store up to 6 units of water. This is what we are going to see. This is the most important logic you should remember for TCS NQT. Water at any index depends on maximum height on the left, maximum height on the right. And here is a formula. Water at index I equal to minimum of left max comma right max minus height. This is our formula. If the value is negative, the water becomes 0. Water is limited by the shorter boundary. Because water will overflow from the side, right? If the rain pours more and more, So we don't have any trapping here. So if it's pour more, so the water will overflow and came this side. So that is what going to happen. So let me explain two terms clearly. So left max and the right max. So the tallest building from the start of the array to the current index, and the right max, the tallest building from the end of the array to the current index. So one is start from the at starting of the building, and the other one is start from the end of the building index of the current element of the current index. So these two values decide how much water can stay at the position. So we have to remember two things, which is left maximum and the right maximum. So yeah, right. So let's calculate water step by step, just like you were doing a exam. So here index 0 equal to height 0. So no building on the left side. So water equal to 0. So our next index 1 equal to height 1. So left maximum equal to 1 and right maximum equal to 3. So water equal to minimum of 1 comma 3 minus 1. So which is 0, right? So if we get minimum of 1 comma 3, which is our minimum is 1. So 1 minus 1, our value is 0. So there is no water will be stored there. So and next our index 2. So in index 2 our height is 0. So left maximum become 1 and right maximum equal to 3. So and again we calculate using that formula. So which is minimum of left maximum comma right maximum minus height. So from the formula our water equal to 1. So we have a 1 unit of water trapped. So our next third index and height we have a 2. So next our left maximum become 2 and right maximum become 3. So if we find a minimum for that, so if we apply the formula here, so the value becomes 0. So there is no water stored there. So after our index is 4. So which we have a element 1. So here also if we apply the formula here, we'll get a 1. So 1 unit of water will be trapped here. So which is this. So in the index y we have a height 0. So and left equal to 2 and right equal to 3. So and water. So we are finding using that formula. So we'll get a 2. So if we get a 2, so that 2 water will be trapped here. So it's just this is 1. Another one is this. So our next index 3, which we have a height equal to 1. So here left maximum equal to 2 and right maximum is 3. So if we use that formula again, we'll get a water trap is 1. So here is the trap. And another our index 7. So which is our height is 3. Right? So our left maximum is 3 and right maximum is 2. So our left maximum is 3 and this is what our right maximum 2. So by using that formula, we get the value 0. So there won't be store any water. So our ninth index, which we have a height 1, right? So if the height is 1, so left maximum is 3, right? And right maximum is 2. So if we use that formula, we'll get a 1. So with the water will be 1 unit, the 1 unit of water will be stored here. So that is what this. So at the index 10, we have a height of the 2. So it's a building is 2. So again, we calculate using that formula. So here, no water unit is going to store. So our next move to the last index, which is 1. So there is no right boundary. So we have only left boundary. So there is no right boundary. So there is no water will be stored. So now let's add all trapped water units. So at first here we have 1 unit and here we have 1 unit and here we have 2 units. So here 1 and here also 1. So 1 plus 1 plus 2 plus 1 plus 1. So we get a total 6 units. So total trapped rainwater is 6. So this is the final answer, and this is how TCS expect you to think also. So why this is important for TCS NQT means? So TCS NQT focus more on logical thinking, step-by-step approach and understanding condition. So if you clearly explain left maximum, right maximum and minimum logic, you will score well even if the question looks tricky. So here is the approach overview. So we have three methods. One is brute force, another one is optimal for beginners, which by using a prefix and suffix array. So another one is two-pointer approach. So here brute force is not recommended for interviews because it takes big of n square time. So here we have to use two loops, like two nested loops. So it takes more time. So brute force is not recommended for any interviews or coding preparations, right? So our next one is prefix and suffix array. So it is for optimal for beginners and pre-compute left max and right max. So we have seen there, right? So left side and the right side, which is maximum, and after we have calculated the values, right? So in that the time complexity is big of n. So which means we use only one loop, right? So it take so we are going to traverse for only one time. So and space complexity, which is big of n. So in a two-pointer approach, so it is a most optimal. So it is best for interview also. So time complexity is so big of n. So which we are going to traverse the array for only one time, and space complexity, which is big of 1. So we are going to visit each and every element for only one time. So two-pointer approach is best, and it is best for interview also. So here is the algorithm. So if you use prefix suffix method, we'll first find the left maximum and the right maximum, and in our for each index we'll do the calculation, which is water plus equal to minimum of left maximum of I minus right maximum minus height. So we have already seen, right? So let's code for the two-pointer approach. So let's create a class here. So trapping rainwater. So our main class. So inside our scanner class. So scanner is equal to new scanner, and inside system.in. So after this, we are so let's get the input for our length of the array. So in array equal to so we have got a input. So after this, we are going to initialize two variables, which is left and right. So we are going two pointer method, right? So we are initializing a two pointers, which is left and a right. So here int left equal to 0 and int right equal to height of length. So array dot So array dot length minus 1. So we are taking a last index of the array. So after this, we are going to find, so we have to find the left maximum and the right maximum, right? So int left max equal to 0. So we are declaring here. And for the right max also. So right maximum equal to 0. So we are just initializing like this. So after that, we have to calculate the water also, right? So how many units are present between the buildings? So for that, we are initializing another one variable. So int water equal to 0. So we have initialized. So here we are going to use the while loop. So we are using a two pointer method. So for that, so in a while loop, left less than right. So left should not exceed the right value. So inside a while loop, we are giving a condition. So if array of left, so which is a height of the left is less than equal to height of the right, which is array of right. So if this satisfies this condition, it will, so we check other if condition. So if array of left greater than equal to left maximum or not. So if this condition also true, we are updating the value left maximum equal to array of height. So array of left. So which is our height. So array of left. So which is a maximum height in the left side. So if it's not, so if does not satisfy this condition, so in a else part we are declaring water equal to water plus left max minus array of height max. Array of left. So we have already seen the formula, right? So water is equal to water plus left max minus right max. So we are checking this condition. So and we are incrementing the left value. So our left part is over here and we are going to see about the right part. So left part is over. So now we are checking for the right part. So in a if condition, we have checked for a left part. So we have checked the left maximum. So in a else part of the first if condition, we are checking for the right. So as like same, same as the left side. So if array of right greater than equal to right max. So if it satisfies this condition, we are upgrading a value right max equal to array of height. So which is array of right. So which is a height of the right side. So if it's not, in a else condition, we are giving a formula water equal to water plus right max minus array of right. So and here we are decrementing the right value. So right is from last index, right? So here we are decrementing the value. So after this we are printing the how many total rain is trapped. So how many water is trapped between the buildings. So na SOPLN. So let's type something. So total trap rainwater equal to, so let's equal to, so let's print water. So let's run this code. So let's give a input as a 12. So let's give a value 0, 1, 0, 2, 1, 0, 1, 3, 2, 1, 2, and 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have given a 12 values. So this example we have already explained previous, right? So so our output. So in a previous example, we have got the output as a 6. So let's see here. So total trapped rainwater is 6. So here our trapped rainwater is unit 1, unit 2, unit 3, unit 4, unit 5 and unit 6. So always use a optimized solution in a interviews in a and also in a coding round. So it will help us to boost logical skill and understanding skills. So how you're going to approach the problem. So this all will be included. So subscribe to our channel. Thank you.